Hey folks, welcome back to the Metal Mill 52 workshop. In this episode you're going to see me work on the spindle housing and the spindle end caps. The end caps are not done. I'm going to make two-piece end caps just like Maddie did on Maddie's workshop, but so that I don't have to do the labyrinth seals for or do the trepanning for that part of the labyrinth seals. But there's a lot to these things. They don't look like much from the outside, but the inside, there's a couple of places that have to be bored out very precisely for bearing races, and then inside tapped, or inside threaded rather, for the end caps. So, and this portion here, this will actually contain not only the bearings, but also a spring assembly that holds the bearing in position. So, one other question I had, or some comments that people made, was, when you slit the cast iron for the clamping, does that change the shape and configuration of the inside diameter? And it does. When I bored this thing out months ago, the fit was just fine. Now I can, what I found out in test fitting this thing was that it did not fit great. So I spent a couple of hours yesterday using my little brake hone to try to open this up just a wee bit so it slid in. So as you can, maybe you can see that it slides in almost all the way now, but I do have to take and it's kind of crude, but pry it with a screwdriver, and then I can pop it through all the way. So it's a good fit. And Dan Hill from Hill's Guns, he brought up a good comment about using the split versus the split cotters. The split casting, when it's tightened down, will make a nice uniform clamping operation. There won't be any opportunity for this thing to shake, rattle, or roll. So that is a good consideration for making it this way, especially for something like the spindle. So I am glad that I did that, and real happy with it. I'm glad that it fits pretty well now. The little boring honing tool was a great idea. I don't know if you can see how nice that honed finish is, but it's smooth as a new jar of Skippy now. But stay tuned for the next few minutes, and I'll show you the different things that I did, both in making the end caps and making the spindle housing. The next thing after this, probably this upcoming week, I do have to make the notches on the spindle end caps, and I also need to make the inside portion. So probably what I have in mind is I'll make up the inside portions first, Loctite them together, and then I'll be able to put these on an arbor and use my hex block to in the mill to machine the little slots. But I'll show you how that's done. Thanks again for watching, everybody. Stay tuned for some more hopefully interesting videos to you, and I appreciate all the comments from everybody, and welcome to the new subscribers. Thank you so much. There's so much good content out there on YouTube that I really appreciate other makers sharing their knowledge and sharing their comments with me. So have a great week, everybody. I'll stay tuned and I'll keep you posted. Here we are taking the initial pass to check the thread count. Thread count sounds like a sheet thing, doesn't it? For 32 threads per inch. Yep, there we go. Looking good. So I turned this down to 1.25 inch diameter. I put a little gully in there, about 40 thou deep, which is deeper than the thread depth. And now I just thread these things. And my game plan is I'm going to make 2 of these end caps, obviously. So what I can do, I'll put the outside details on this thing, and then just drill and bore the center part, and I can drill and bore enough for the depth of 2 of them, and then part this one off and make the second one in a cylinder. There I'm boring out the center of the end caps to 940 thousandths. I bored them out once, I was about a thou shy, so I'm taking, as they say, a spring pass. I hope it doesn't take off too much material. It's always a little bit of a gamble, but hopefully it'll be close to what I need. So doing a little work on the spindle. My first thing to do is to chuck in my 4-jaw and perfectly center a piece of 1 3/4 steel was a little oversized, so I turned it down to a perfect, kind of a snug sliding fit on the housing. And then I've drilled out, this is the same piece that I made the end caps out of, but I've drilled it out and just reamed it the 5/8 inch all the way through. I did all the way to 4 inches here, so the next step will be to drill and bore out the cavity on this side for the bearing, and then drill and bore out and thread the inside for this end cap on this side. Then I'll flip it around, carefully recenter it, and do the detail stuff on the inside of the other one, hoping to get that, at least the spindle housing, done this week. Okay, this should be the last pass for boring out the space for the bearing space on this part. Got the DRO zeroed and did a couple of test fits, and it looked good. Okay, I was a little worried, honestly, that my hole was not the right size, but as you can see, I got the bearing race in there now. Let me see if I can tell that it just barely fit in there. I had to press it in. I mean, not press, but press with my fingers. And I'm going to pull it out before it gets stuck. Try to, anyway. Okay, there we go. That was close. I was afraid it got stuck. But to describe what I was talking about, because I'm going to have to bore out the first 1/4 inch of this tube anyway, a little bit more, so that I can thread it for the end cap, I use those couple of passes to get my exact right inside diameter. So it's a little loose the first little bit, and then I put in a little bit further, and it's not loose at all. In fact, I was afraid it was stuck in there, but it fits perfect. No rattle, nice sliding fit, just like it talks about in the book. So I got that done. The little ordinary carbide boring bar. Now I'll bore it out a little bit more. I did the math on this. I'll report it if the math works out correctly. I'll let you know for the inside diameter for the 32 TPI, because the book doesn't call it out. Okay, I'm pleased to report I finally ended up with a very good fit on my end caps. The end caps aren't done. I still need to make the inside part that will have that trepanned kind of space in there, but I'll Loctite them together much like Maddie did. But a little trial and error and a little goof up. You can see I overran my threads there. I'm gonna have to clean that out in a minute. But the inside diameter, now your mileage may vary, but the outside diameter of my threaded portion is like right at 1.25 inches. So my inside diameter, I actually had to bore that out again. I kept threading it, and it was still too tight, and it wouldn't fit on there. So the inside diameter that I ended up with for the threads was 1.235 inches. Okay, so who knows? But it works. It actually is a pretty snug fit. Let me show you right when I get to the end there. It's a little snug. So I think I'm going to leave it just like that, because we want this to be fairly snug and make a nice seal, because there's going to be oil inside the spindle. But that's what worked for me. So like I said, your mileage may vary. I wish they would have called it out a little bit better in the book. It is nice. The internet has tables that you can look up. That's where I came up with my initial inside diameter for the threaded portion of 1.218. But that just wasn't enough. I needed to open up to 1.235, like I said. And that works fine for these threads that are right at 1.25 inches on the outside diameter. So I'll keep you posted as we make progress. Okay, for this segment, I just kind of wanted to talk about what I've done so far and what as we prepare. So last night, I got this side bored out, drilled and reamed out a 5/8 inch hole all the way through, and I ran the reamer through again after I was finished. So I bored this side out and I threaded it for the end cap. And basically, this portion is going to be the rear portion. This is going to be where the spring pocket goes, and the bearing on this side will be the pulley side of the spindle. So what I'm getting ready to do now is cut it off, and just because I want to make sure I'm accurate with my final length, I'm going to mark the 3. I'm using my DRO. I'll mark the 3 3/4 inch thing with a freshly sharpened cutoff tool, but the only hole in there that's back this far is the 5/8 inch hole. So I don't want to rely on this thing being perfect. So I'm basically going to mark the hole, and I have enough room, as you can see here, just to move this cutter over 100th or so and cut behind, so that when I take the spindle out, flip it around, then I can cut it off to the exact right length, and the exact right length will be marked for me here. Love my little Noga tool holder, or a measuring instrument holder there. As you can see, I've got the spindle is cut off at the 3 3/4, actually a little bit longer, and I've gone around and carefully centered it now, perfectly centered, and you can see this is the mark I was talking about. So my first step here, now that I've got it centered and mounted and tightened, is to face this off to the exact 3 3/4 inch length. The other thing I point out that I did was I marked where the empty part was, so to speak, the part that I machined out, and I made sure to push that back so that's inside the chuck, because I didn't want to clamp down real hard on the hollow part with the forejaw, because who knows, that could distort that housing a little bit. I drilled out the 7/8 inch portion and got it out to about a little over 2 inches, and then I just used the reamer here. You can see that I got a nice flat bottom hole in there. Use the reamer here. This is a 7/8 inch reamer to do the last probably like 50th or so, just to give it that nice flat bottom. I want to take a quick shot of the inside of the bore of the operator side of the spindle housing before I machine the inside threads. So the first opening here, this is 1.235 for mine, and then I'm getting ready to thread that portion, that first 1/4 inch. The remaining portion, which is just under a 1/4 inch, about 3/16 of an inch, that's the fit area for the bearing to go in, and I've tested that out and it fits fine already. And the next portion that you see is the 7/8 inch chamber that the spindle will be in. And down here, I can feel it with my finger. It's probably hard to see, but you can. There's the 5/8 inch hole that's in the center that kind of separates the front half from the back half. So getting ready to thread. All right, threading is now complete. It snugs up there really good. I'm not going to do it because I needed to put a vice grips on it to loosen it up. But a couple little tips. It's hard to believe, but like I said, I mean, I gave the dimensions and it actually worked out well with the initial hole at 1.235. That was the diameter that I used for the threading. And of course, like I said, the outside diameter of this is 1.25 inches, right on the money. So interesting, but it worked out well. The next thing, while I've got it all centered up, I feel a few ridges and stuff in here. So I'm going to take some files and just kind of deburr the inside. We have the threaded portion, then we have the portion where the bearing sits, and then we have this portion in the very center that the spindle will go through. So I'm going to deburr this, and when I'm satisfied that everything is as good as it can get, then I'll take it apart, take this out of the chuck. The only remaining step will be to drill and tap a hole for the oil fill on here. So we'll do that and bring you back for that. Okay, just to show you that, I use this little deburring knife. It's something I bought a set of tools from a retired machinist, and it had this thing. I couldn't figure out what it was for a while, but he had taken an old triangular file, obviously, and then ground it down, and it makes an excellent deburring tool. It was just the thing for deburring both the center part here and then the bearing part. So I've just double checked that the everything fits very smoothly and nice, so now I can take this out and we'll drill and tap for the oil. Alright, here I've drilled and tapped. I decided to use an 832 screw for the oil fill on my spindle, and just basically because I had one, but I had a countersunk one. And also, I was going to make the hole 2 inches back, but I decided that was going to be pretty close to that little bulkhead, so I ended up making it 1.75, 1.75 inches. But wanted to show, this is the little setup I use. I use this kind of thing a lot for anything to do with cylindrical objects in the mill vise. So now all I gotta do is countersink it for the screw. Alright, here's a little oil fill hole. I use the 8/32 or number 8 32 thread per inch drill and tap, and a little ordinary countersink. These are the little kind you can get from Harbor Freight here in the States, and it works great. So I just went down, and then you might be able to tell I domed the screw a little bit just in the belt grinder. I just took the edge off of it so that it wouldn't be sticking up, but it's all down below the edge of the hole now, so the spindle ought to fit. I do need to cut the length of the screw, so I'm going to have to mark that, and I'll bring you back in a minute. Alright, I finished shortening the little 832 countersunk screw that goes in. That'll be the oil filler, and it's tiny. It took a little bit of cutting and grinding, so it's got about 3 threads. Probably hard to see. I'm kind of glad I used the number 832 instead of a 1032. But that's enough threads, and looks good. This will be the last segment, I think, because I'm ready to go in and eat supper, but I'll do a intro segment to the Spindle Housing, and we'll talk about what's next after that. But thanks again, everybody. Appreciate y'all watching, and I love the comments. That's very helpful and interesting to me.